for today. I can factor quadratic trinomials. Read it together. 1, 2, 3. I can factor quadratic trinomials. So what are quadratic trinomials? Quadratic trinomials are expressions of 3 terms, and the highest degree is 2. Copy that, please. Expressions of 3 terms, and the highest degree 2. Examples: x squared plus 3x plus 2, x squared plus 8x plus 7. Copy that. I'll give you guys 30 seconds. Okay, so according to the definition, let's see. Expressions. Are these expressions?
Yes.
Do they have 3 terms? Let's see. 1, 2, 3. 1, 2, 3. Yes. Is the highest degree 2? Let's see. The degree of this term is 2. The degree of this term is 1. The degree of this term is 0. So for those of you that still have this confused since we saw polynomials, the degree is the exponent on the variables, or the sum of the variables of each term. So this one is 2, this one is 1, and this one is 0. This one is 2, 1, and 0. So the highest degree is 2. Okay? So let's go to non-examples. Non-examples. X squared plus 3x plus 2 equals 0. Negative 3 plus x equals 10. 2 equals 2x. And the last one is x squared. Copy those. So tell your neighbor why all of these are non-examples. All right. So let's see. Stephanie, why are these 3 non-examples? They're equations, and right now we're back at where? Expressions only. Okay. How about this last one? Why is this one a non-example? Taylor C.
Because why is it an example?
Therefore, the most important thing to remember about quadratic trinomials, they have to be expressions only, 3 terms, highest degree 2. Copy that. All right, write these next steps, please. It's only 6 steps. Step number 1, factor out the GCF. Step number 1, factor out the GCF. Step number 1, factor out the GCF.
Step number 1.
Step 2, open 2 parentheses. Step number 2, open 2 parentheses.
Step number 2.
Step number 3, factor the first term. Step number 3, factor the first term. Step number 4, draw a diamond and factor the last 2 terms. Draw a diamond and factor the last 2 terms. Number 5, write your factors. And number 6, check. Copy that, please.
Number 5 what?
Write your factors. And number 6, check. So here goes the steps once again. Step 1, factor out the GCF. Have we done that? Yes. Step 2, open 2 parentheses. We know how to draw 2 parentheses? Yes. The last 4 steps are the ones that I'm going to show you today. However, some of that you already know because we did that at the beginning of the year. So this should be fairly easy. However, before we get started with this process, I'm going to show you how to factor using tiles. So remember the algebra tiles from the beginning of the year. Okay, so here we go. So let me show you. So the tiles that I showed you at the beginning of the year were these. This one, right? This was x squared. These were considered x's, and these were considered ones or units. For those of you that don't remember, you don't have to copy this, just pay attention. I said this one, let's say this measures 1 and 1, and since it's a square, 1 times 1 is 1, and from now on I said it's considered a 1. But when you flipped it, it was a red one, remember that? And the red ones were what? Negative ones, remember that? So then I said, so this side of the green measures about the same as the yellow, so we say this measures 1. The only side that we didn't know was this one, so we said this is x. The area of this rectangle is 1 times x, which is x. That's why I said from now on these are known as x's.
Yeah.
But if they are red, they are negative x. Are we there so far? And then from there I said this side measures about the same side as the green, so we said this is x. Since it's a square, this is x, and the area is x squared. So that's why these were considered x squares. Are we there so far? And the red ones were what? Negative x squared. So from there, let's see. What do we have here? What expression? We have x squared plus 3x plus 2. Are we there so far? So then after that, I said, we're going to work on something called the area model. Who remembers the area model? Very good. And I said, we're going to make a rectangle out of these tiles. So look at how many green tiles? 3. How many yellow? 2 and 1 blue. I'm going to make a rectangle out of this. Here it goes. 1, 2, 3 green, and 2 yellow. Do you see the rectangle? All right. Once we have a rectangle, now we can actually factor. Watch. Hold on. Hold the questions. Let me just go through this. We have x squared plus 3x plus 2. We need to come up with the dimensions of this. So this is this. Is that correct? So watch. Let me show you how to get the dimensions. What does this side measure? X. What does this side measure? 1, so this is x plus 1. What does this side measure? And what does this side measure? 2, so this is x plus 2. So my dimensions are x plus 1 times x plus 2. Does that make sense?
Yes.
And if we were to draw, watch, if I was to draw this like this without the actual colors, and I wrote this here, does this look familiar? The area model, right? But the only thing now you're seeing it with colors here. Are we there? So, do you know how to get these dimensions? Okay, let me show you another one. Here it goes. So now I have 1x squared, 1, 2, 3, 4, 5 x's, and I have 1, 2, 3, 4, 5, 6. So I'm going to make you a rectangle for this one. Here it goes. 3 on this side, 2 on this side, 6 right here. So I have x squared plus 6x plus 6. Now, without writing it down, I want you to, in the air, try and figure out this length and this length. Oh, 5x. Yeah, I did that on purpose to see if you were paying attention. 5x. There it is. So,
What do you mean? Wait, hold on.
get me the measurement of this side and the measurement of this side.
Ah, got it.
Tell your neighbor the dimensions, please. We got x plus 2 times x plus 3. Okay? So let's see. This side is x, this is 2, this side is x, this is 3. So therefore x plus 2 times x plus 3. Are we there so far? Yes?
So if we could square, you take x squared, you wouldn't count x squared because the...
No, right now we're looking at the side, not the area.
Okay.
All right? I'm going to give you, yeah,
So you only do like one side?
the sides, yeah.
But would it ask you like which side to do, or would you...
It doesn't matter. Let's see. So the question was, I just do one side. Does it matter which side? Well, let's see. Let's say I started down here. What is this measurement?
X?
And what is this?
Oh, wait a minute.
3. What is this? X. And what is this? 2. So it doesn't matter which side you use as long as you get the measurements from that. So with that said, let me give you another set. I'm going to give you one of these, 2 of these, and 1 of those. So, with that said, can you picture the rectangle? Okay? Who can picture it? Okay? Who can give me the dimensions now that you pictured it? Don't say it out loud. Keep it to yourself. Okay? If you don't picture it, here it goes. Who saw that? Okay, and the dimensions for this one, let's see, what do I have? X squared plus 2x plus 1. Who can give me the dimensions? Robert? X plus 1 times x plus 1. Hands if you saw that. Okay? So, that's one way of doing it. We're not going to go that way right now. I want you guys to practice the other method so we can go a little bit faster. So with that said, copy this down, please. Example 1A. Example 1. It says, factor x squared plus 15x plus 36, and check your answer. Write that down, please. Factor x squared plus 15x plus 36, and check your answer. Write that down, please. At this point, pens down, pencils down, pay attention. Here it goes. Please, pretty please, just pay attention. Don't write anything down. I'm going to go through the entire process, okay? So follow along. It's 5 easy steps and then the check, but I need you guys to focus. Here it goes. Step number 1. Step number 1 says factor out the GCF. So first I need to ask the question, is there a number that can divide into each term? No, the only number is 1, because this one doesn't have a coefficient. Does everybody see that? Okay. Is there a variable on each term? No. Therefore, at this point, step 1, we don't have any GCF, so we go to step 2. Are we there so far? Step 2 says open two parentheses. Focus, please. 1, 2. Step 3 says factor the first term. Here's my first term. How can we factor x squared? That becomes what? X times x. And notice that I wrote them in 2 different parentheses because it's x times x. Are we there so far? All right. Okay, let me stop right there. So, at that point, step 4 says draw a diamond and factor the last 2 terms. Watch, I'm going to draw a diamond. And I'm going to organize this in here. So pay attention. Here it goes. The middle term always goes on the bottom square right here, 15, and you're going to put a little plus right here. The last term always goes on top, and you're going to put a little multiplication. So watch, pay attention. I'm going to focus right now on the last term, this one. I'm going to write all pairs of factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Are all those my pairs of factors? Yes. So now, all of these multiplied give me 36, right? But only one pair of these will add up to 15. That's why I put a plus here. Who sees it already? All right, and that pair are 3 and 12. That goes right here, 3 and 12. Well, guess what? Those are the 2 numbers that we need for here, x plus 3, x plus 12, and those are my factors. Bam. Copy that, please. Okay, we'll go over it again.
So is there always multiplication and
This will always be multiplication, and this will always be addition.
Oh, okay. So there's nothing special?
Nothing special. It always has to be organized like that. Go. Copy that. As you're finishing copying that section, here it goes. I'm going to go over the steps again. Step 1, we check for GCF. Was there a GCF? No. Step 2, I open 2 parentheses. There it is. Step 3, factor the first term. The first term was x squared. That became x times x. Are we there so far? Step 4, I drew my diamond, and I organized the last 2 terms here so that I can factor them out. The middle term always goes on the bottom, and the last term goes on top. The bottom one is the sum, the top one is the factor. We always go with the factor because factor means what? 2 or more numbers that multiply, right? That's why we need to look for the pairs of factors of that number. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. And one of those pairs that multiplies to give us 36, added to give us 15. So when we add 3 and 12, that gave us 15. That's how we get x plus 3, x plus 12. Are we there? Now, could we write them the other way around? Yeah, x plus 12, x plus 3. Yes?
So the factors of 36 will always add up to 50? Or like
One pair will always add up to 15. Yeah. How come we didn't use 36? Because 36 plus 1 is not 15. It's only 36 up here. It has to meet both of them. 3 times 12 is 36. 3 plus 12 is 15. Now, are we done? No. What's our last thing? Check. So I want you to write check. And this should be the easy part because I showed you this at the beginning of the year. Check this out. Look up. This is how we check. What is that?
Area model.
Area model. So therefore, x times x, x squared, 12 times x, 12x, 3 times x,
3x.
3 times 12,
36.
36. So my first term is x squared. Draw your peanut right here. 12 plus 3, that's 15x. And then we end up with 36. Is that what we started with? Yep. That's how you check. Boom. Bam. How we doing? Let's do another one. Let's do it together. So like that we can go a little bit faster. Here we go. Copy this one. Oh. Copy this one. Example 1A. 1A. Here we go. Example 1A. Copy this down, please. X squared plus 10x plus 24. X squared plus 10x plus 24. So let's see. Let's go through all steps. Step number 1. Do we have a GCF? No. Step 2, we open 2 parentheses. So open 2 parentheses underneath. Step 3, factor the first term. What's my first term? X squared. That becomes what? X times x. 1 in each parenthesis. Step 4, draw a diamond. But check this out. To make it easier, look up. Instead of drawing the whole thing like this, from now on, so that we don't spend too much time drawing, we'll just do that.
I knew it.
And from now on, instead of calling it the dime, we're going to call it the Power Rangers.
Power Rangers.
So, no? So check this out. What's the middle term? 10, that goes here, and that's the sum. What's the last term? 24, that goes on top, always. Yes. The middle term, it always goes on the bottom. No, it always goes on the bottom. Always goes on the bottom. Always on the bottom. So factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and we're done, right? So which one of those pairs adds up to 10? 4 and 6. So we write that here, 4 and 6, and those are what's missing here, x plus 4, x plus 6, and those are known as factors. Why are they factors? Because this is multiplying this. And what was the definition of factors? Numerical variable expressions that multiply, or 2 or more numbers that multiply. Yeah.
So, can you put 6 on the other side and 4 on the other side?
Yeah, I just said that earlier. We can switch these. X plus 6, x plus 4.
Oh, okay.
Yeah, go. I'll let you know about that when we get there. Check this. Here we go.
Can I do it? Can I do it?
Area model. Do it on your paper. Here we go. X plus 4, x plus 6. This is x squared, 6x. This is 4x and 24. My first term is x squared. I'm going to draw my peanut right here. That's 10x and 24. Is that the same thing we started with? Yes. How are you feeling? Good? Okay, let's do the next one. See if you can do the next one by yourself, the whole thing. I want you to find me the factors, and then I want you to check. Here we go. Ready? All right. Example 1B. Copy that, please. It's x squared plus 7x plus 12. Find me the factors, and then at the end, I want you to check it. Go. All right, here we go. Here goes the whole process. First of all, is there a GCF? No. Open 2 parentheses. Factor the first term. Draw your Power Rangers. The 7 goes down here. It's a sum. The 12 goes up here. It's a product. The factors are 1 times 12, 2 times 6, 3 times 4. Which one of those gives us a sum of 7, 3, and 4? But I could write 4 and 3. Is that correct? X plus 4, x plus 3, and those are my factors. And we can check. Here's the area model. X plus 4, x plus 3. This is x squared. 3x, 4x, 12. So therefore this is x squared plus 7x plus 12.
Mr. Q, on the test, did you get mad at my stuff?
Anyways, here we go.
What?
Hold on. So, any questions with the process? No. Question, yeah.
Would it be like wrong still if I put x plus 3 in the first one?
No, like I said, you can either write x plus 3, x plus 4, or x plus 4, x plus 3. It's like this. Look up, please. Look up, please. Does it matter how I write 3 times 4 or 4 times 3? Will it give me the product of 12? Yeah. So the order doesn't matter, right? That's why we covered that at the beginning of the year. It was the commutative property of multiplication, right?
Yes.
All right. So with that said, do this next one by yourself. For this next one, you don't have to check. I just wanted to show you how to check. For this next one, I want you to do everything else, though. All this, and see if you can go a little bit faster. Here we go. Example 1C. I want to see how you do with this one. X squared plus 6x plus 5. Go. All right, here he goes. Was there a GCF? No. Open two parentheses. Factor the first term. Power Rangers. We got 6 down here, 5 up here. This is the product, right? What two factors of 5? What are the only factors of 5? 1 times 5. Do they add up to 6? Yes. X plus 1, x plus 5. Those are my factors. Are we there so far?
Yeah.
Huh? That's the home plate, yes. Let's do another one. Copy this one. Go. Let's see if you can do this one in 15 seconds. X squared plus 6x plus 9. Go. All right, here we go. What'd you get for your factors? Taylor, B. Factors.
Oh, x plus 3
X plus 3
and x plus 3.
times x plus 3. Hands, have you got that? What's another way of writing this, by the way? Yes.
Wait, another way to write it?
Yeah.
Oh, x squared.
Close. X plus 3 squared. Copy that, please. Whenever you identify that these are exactly the same factors, make sure you write it like this in simplified form. If you identify it. Okay? Let's continue. Next one. Copy this one. See if you can go a little bit faster. X squared plus 8x plus 12. Go. So, I see some of you doing this. GCF, you do this. You do this. But then you skip the writing the pairs, so you already think about it, and you're like, oh, 2 times 6, x plus 2, x plus 6. These are your factors. Hands if you got that. So now, that's okay. If you're skipping writing the order, the factored pairs, that's okay. But whenever you get stuck, make sure you do what? Write out your factored pairs. Are we there? All right. Yeah. Copy this one. Now let's start with some negatives. See how we do with those. Example 2A. X squared minus 8x plus 15. We're going to do this one together. Here we go. Write it down, please. I don't want it in your noodle. Here it goes. Do we have a GCF? No. Open two parentheses. Factor the first term, x and x. Let's draw our Power Rangers. There it is. Middle term goes down here, -8. That's our sum. The last term goes up here. That's our product. So, think about it. What are factors of 15? 1 times 15 and 3 times 5. Which one of those pairs gives us 8? 3 and 5, right? But then this has to be a negative, which means both of them have to be negative. So what is negative times a negative? Positive. What is negative plus a negative? A negative. So therefore this is x minus 3, x minus 5, and those are my factors. See what we're doing? Okay. What's that? I know. Let's do another one. Here we go. Yeah.
So, would that mean that the answer would be a positive though?
Yeah, it's positive 15. Negative 3 times negative 5, that's positive 15. Yeah. Okay, let's go to the next one.
Wait.
Copy this one, please. Example 2b, x squared minus 5x plus 6. Go. All right. What are your factors, Mari? X minus 2 times x minus 3. Hands, have you got that? That is correct. So once again, the process. Open two parentheses, factor the first. Power Rangers, negative 5, that's a sum. The 6 is the product, so what factors of 6 added to 5? 2 and 3, but they need to be negatives. Are we there? Okay, copy this next one, please. See if you can go a little bit faster. 10 seconds. X squared minus 13x plus 42, go. Okay, what'd you get for this one, Carissa? X minus 6 times x minus 7. Hands, if you got that. That is correct. Okay, so now let's switch it a little bit. We started with the middle one with negative. Now I'm going to switch it now that the last one is a negative. Copy this one, example 3a. And we're going to do this one together. Copy that, please. X squared plus x minus 20. First, do we have a GCF? No. Open two parentheses. Factor the first term, x and x. Draw your Power Rangers. What goes down here? No. 1. That's the sum. This one is negative 20. That's our product. So this is where it's going to get a little bit tricky. Hold on. I'm going to write out the factors so that you see them first. 1 times 20, 2 times 10, 4 times 5. Which one of those, listen to what I'm about to say, which one of those adds or subtracts to give us 1? 4 and 5. Watch. 4 and 5. 4 and 5. Therefore, one of these two has to be a negative because this one is a negative. Okay, hold on. Stop yelling out answers. Here he goes. Let me show you how to be sure. When this is a negative and this is a positive, that means one of these two has to be a negative, right?
Yes.
The way we know what number is which, this number is going to tell us the sign for the big number. This number is going to tell us the sign of the big number. Which is the big number? What sign is this? Positive, so the 5 is a positive. Guess what? The 4 is the negative, so this is x minus 4, x plus 5. Why is that? Because negative 4 times 5, that's negative 20. Negative 4 plus 5 is 1. And those are my factors. Are we there so far? Okay? So, one more? Copy this one, please. X squared minus 3x minus 18. This is the last one. There's no GCF, so I'll get you started. Negative 3, that's the sum. Negative 18, that's the product. See how you do with that. Go. Here we go. So, factors of 18 are 1 times 18, 2 times 9, and 3 times 6. Which one of those adds or subtract to give us negative 3? Taylor, C.
3 and
How do you know that the 6 is negative?
3 is negative.
Because this one is negative. That is correct. X plus 3, x minus 6, factors. A good one. Our home plate for tonight is found on pages 538, 539. There's tutoring today. If I don't see you guys tomorrow. Bye.